Hello friends, welcome to State Engineering Service Examination section of Winds of Change. We will cover so many questions from the civil engineering topic here from expert IES. You may contact us at windsofchange2020@gmail.com, and for the study material you can download from the link given in the description box. You can subscribe to this channel to stay updated for more videos. You may like these videos if you feel useful for you and comment for any feedback. Welcome to 160 questions of irrigation and hydrology. In this video, we will cover question number 1 to 30. These will be explained by expert IES. So let's begin. First question. Lacey's equation for calculating flood discharge in river is V equal to 10.8 R raised to power 1 by 2 S raised to power 1 by 2, or V equal to 10.8 R raised to power 2 by 3 S raised to power 1 by 2, or option C, V equal to 10.8 R raised to power 2 by 3 S raised to power 1 by 3, or V equal to 10.8 R raised to power 1 by 3 S raised to power 2 by 3. Just think about it. If you know the formula, then only you can answer this question. So that's why you should know all the formulas of Lacey's equation related to canal design. Now just think about it. The answer is option C, that is 10.8 R raised to power 2 by 3 S raised to power 1 by 3. You can obtain it from this relation V equal to 10.8 R raised to power 2 by 3 and S raised to power 1 by 3. These three equations in the starting, these are the primary equations of Lacey's. These are very important to memorize. All these equations are very important to memorize for the Lacey. Okay, next question. Lining of the irrigation channel increases with waterlogged area, decreases with waterlogged area, does not change the waterlogged area, or none of the above. Now just think about it. If we provide lining of the irrigation channel, that means it will prevent the seepage of the water. Okay, so it will definitely decrease the water that can percolate to the adjacent field, and waterlogged area that can form there will be decreased. There will not be possibility of getting a waterlogged area if you are lining the irrigation channel. Okay, so it will decrease the waterlogged area in the vicinity of it. When the canal section is made fairly watertight by providing lining, the seepage loss is reduced to quite a good extent. Okay. Next question. If average particle size of silt in millimeters is m, then the Lacey's silt factor F is proportional to. You should know the formula for it, then only you can answer it. If average particle size is denoted by m, which is in millimeter, then the Lacey's factor F is proportional to. Can you recall the formula for Lacey's silt factor related to average size of the particle? So it will be m raised to power 1 by 2. That is option B. Why so? Because silt factor F equal to 1.76 root D. This formula is very important. 1.76 root dm, that is average size of particle. So it is proportional to under root of average size of the particle, that is d raised to power 1 by 2. Okay. Next question. Pick up the correct statement from the following. Escapes are essential safety valves in a canal system. Or the escapes must lead the surplus water to natural drainage. Or escapes are aligned to take advantage of contours of lower values, or all of the above. Can you recall this escapes, canal escapes? Okay, I'm gonna tell you. Canal escapes, this all of the above statement are correct. These are the escape channel. Okay, here it is being provided for tail escape. Here you can see that these are the steps provided: crest, weir trend, and pitching. And this is the top of the canal bank. From the canal we are obtaining the escape channel. Now escapes are essential safety valves in a canal system, which is a correct statement. The escapes must lead the surface water to natural drainages. Escapes take the surplus water from the canal to the natural drainage. Okay, if the water level exceeds the full supply level in the canal, then the escapes channels will comes into the picture. They will take the surplus water and take it to the natural drainages. Now the escapes are aligned to take advantage of the contours of lower values. Since canal is provided along the ridge line of the catchment, so the escapes channels will take the water along the lower values of the contour. Okay, so all of the above are the correct statement. Next question. If the water table is comparatively high, the irrigation canal becomes useless due to large amount of seepage, waterlogging in the cultivated areas, uncertain water demand, or all of the above. Think about it. If water table is comparatively high, means it is at a higher level, irrigation canal becomes useless. Why it is so? There will be large amount of seepage, which is correct. Waterlogging of the cultivated areas, that will occur since water table is high. This is a reason for the water logging. If the high water table, there will be higher water logging. Okay, and uncertain water demand. Since there will be uncertain water demand, you cannot say at a particular time that how much water is required, because there are through the water table that can be obtained by the crops. Okay, so all of the above will be the correct answer here. Okay, option D. Next question. The field capacity of the soil depends upon capillary tension in the soil, porosity of the soil, both A and B, or neither A nor B. Think about it. Field capacity of the soil. Field capacity will depend upon, the answer is both A and B. Now field capacity will depend upon both of these. The quantity of the water that soil can retain after flowing down of a gravitational water is called the field capacity. Okay, it is the water that is retained by the soil particle after all the water which can seep down, which can percolate, that is under the gravity, they will get inside and join the water table. Now those water has been escaped. Now only the water will be remaining which are in the capillary tension in the soil. Okay, so as much there will be the porosity in the soil, in that only, in the pores only, these water can be filled. So that is why the field capacity will be more. It depends on the chemical composition of the soil, which means type of the ions present and hence pH of the soil also, size of the soil particles and their aggregation form pores in the soil. That is why porosity is required. Large pores take part in the percolation of water in the soil, but small pores hold water by capillary. This line is very important. Small pores hold water by the capillary, which is finally utilized by the plant. Okay, these are the mainly the useful amount of water. Next question. A land is said to be waterlogged if its soil pores are within a depth of 40 cm are saturated, a depth of 50 cm are saturated, or root zone of the crops are saturated, or all of the above. Now a land is said to be waterlogged. Which condition will lead to the waterlogging? Which condition is called a waterlogging condition? Just think about it. Waterlogged condition is observed when the soil in the root zone of the plant that is not be able to obtain proper air for its growth. We require not only the water but also the ventilation of the soil, the air in the soil, that are very much important for the growth of the plant. If it is being filled by the water, then the circulation of the air will not be possible. Okay, so C will be the correct answer, that is root zone of the crops. If they become saturated, then that condition is called the waterlogged condition. Okay, next question. The area between the ISO height 45 cm and 55 cm is 100 square kilometer, and between 55 cm and 65 cm is 150 square kilometer. The average depth of the annual precipitation over the above basin of 250 square kilometer will be. Now just think about it. It is very easy question. You just know the isohydral method of finding out the average precipitation over an area. You can use your notepad also. Okay, so let's solve it. In the isohydral method, the average precipitation can be obtained by the formula sigma A into P1 plus P2, that is Pn plus 1 divided by 2 upon total area. Okay, now here first of all P1 plus P2 by 2, in the first condition it is being given 45 cm 55 cm, so average precipitation is 50 cm and the area corresponding to it is 100 square kilometer, so 50 into 100. Now plus in the second condition 55 cm and 65 cm, so average precipitation is 60 cm and the area is 150 square kilometers, so its multiplication will be, so it will be 60 into 150. Now divided by total area, that is 250 square kilometers. So answer that will comes out to be 56 centimeter. Option C will be the correct answer. Okay, this is isohydral method. Next question. The normal annual precipitation of the stations X, A, B and C are 700 mm, 1000 mm, 900 mm and 800 mm respectively. If the storm precipitation of three stations A, B, C are 100, 90 and 80 mm respectively, then the storm precipitation of the station X will be 70, 80, 90 or 105. This is simple question just related to the finding out average precipitation of one of the station. Now the formula that will be used here, that is very important. The formula that will be used here will be Px equal to Nx upon m into P1 upon m plus P2 upon n2 up to Pm upon Nm. Okay, now how we will find it out here? Since precipitation, normal precipitation as well as the storm precipitation is given for ABC station, and for the X station we have to find out. Now for the X station it is Px upon Nx equal to 1 upon m P1 upon N1. Now P1, that is precipitation of A, is 100 mm and precipitation, normal precipitation of A is, this is 700 for X, so for A this will be 1000 mm. Now P2 upon N2, it is given here, that is 100 upon 1000. Now P2 upon N2, now precipitation of B is 90 mm and normal precipitation is 900 mm, so it is 90 upon 900. Now for third one it is 80 mm for C and normal is 800 mm, so it will be 80 upon 800 and total values M are 3, 1, 2 and 3 ABC, and normal precipitation of X is 700, which is given here, so it will be 700 upon 3 into 100 upon 1000. This 3 will be 0.1, 0.1, 0.1, so total value will be 0.3, 0.3 upon 3 will be 0.1, it will be 700 into 0.1, which will be 70 mm. That is option A will be the correct answer. Okay, easy question. Moving on to the next question, the 10th question. The level of the floor of the siphon aqueduct can be obtained by subtracting the depth of the culvert from the canal bed level, by subtracting the thickness of the culvert plus the depth of the culvert from the canal bed level, or both A and B, or none of these. Think about it, the image of the siphon aqueduct in your mind. First of all, in the siphon aqueduct, the canal is above the natural drainage, and high flood level of the natural drainage is usually above the bottom level of the canal or the floor level of the canal. Okay, now we have to obtain the level of the floor of the siphon aqueduct, means bottom level, that is the level of the floor of the drainage. Then it will be obtained by subtracting the thickness of the culvert. Now let's see, in this one, from the canal bed we have to find out, this is the canal bed and this is the level of floor of siphon aqueduct. Okay, now if we know this level and we have to obtain this level, then this much value will be subtracted. Okay, this value should be subtracted here. So this value will be obtained by subtracting the thickness of the culvert plus the depth of the culvert from the canal bed. This is the depth of the culvert from the canal bed and this is the thickness of the culvert. Okay, so these two will be taken minus from this whole value, then the value of the level of the floor of siphon aqueduct can be obtained. Okay, so option B will be the correct answer. Next question, FSL means full supply level of the canal at its head with respect to parent channel is kept at the same level, 15 cm lower, 15 cm higher, or none of these. Now in the canal, full supply level of the canal at its head with respect to parent channel, so obviously first of all it will be kept lower, it cannot be kept higher level. Okay, and how much lower, that will be given here, that is 15 cm lower. Option B will be the correct answer. Let's say this is the parent canal and this is the off-taking canal. Now the level of this canal, of the off-taking canal, should be kept 15 cm lower from the full supply level of the main canal. Okay, got it. Next question, according to Khosla, the exit gradient of the surface flow. This is a question of the Khosla theory of exit gradient. It depends upon B by D ratio. Independent of B by D ratio is independent of the depth of the downstream cutoff walls, or none of these. Can you memorize the Khosla's theory of exit gradient? So I'm going to tell you here. Khosla's theory, option A will be the correct one. It will be dependent upon B by D ratio and it will depend upon downstream cutoff wall depth also. This is the downstream cutoff wall, the depth of it is D and it depends upon D because exit gradient according to Khosla is given by H upon D 1 upon pi root lambda. Okay, this is the formula for the Khosla's theory to find out the exit gradient. Now where lambda is 1 plus under root 1 plus alpha square by 2, where alpha is B by D, that is B by D ratio. Okay, so main component, that is B by D ratio, from this lambda will be obtained and from lambda we will obtain exit gradient. Okay, So that is why it will be depend upon the B by D ratio. You can find it out here. This is the Khosla's theory, and this is very important theory. You should memorize it. I have explained about it in the video of irrigation engineering. You can find it out from the link given in the description box. Next question. If the intensity of the rainfall is more than infiltration capacity of the soil, then the infiltration rate will be equal to rainfall equal to infiltration capacity more than rate of rainfall or more than infiltration capacity. Now just think about it. What is infiltration capacity? Infiltration capacity is the maximum value of the infiltration rate. Infiltration rate cannot go beyond this infiltration capacity. Okay, so obviously if the intensity of rainfall is more than this infiltration capacity, then the infiltration will be at infiltration capacity only. Okay, so answer B will be the correct answer. That is equal to infiltration capacity. Infiltration capacity, the maximum rate at which soil and rocks can absorb rainfall. Okay, next question. The maximum permissible eccentricity for no tension as the base of the gravity dam is? Very easy question. B by 2, B by 3, B by 4 or B by 6. We have to find out the eccentricity for no tension at the base of the gravity dam. Can you recall it? You should know it directly from the elementary profile of the gravity dam. Just think about it. It will be given by B by 6. Equal to B by 6 is for no tension. Okay, if the eccentricity is from this to this, that is this much value will be B by 6. In this B by 6, if this resultant lies here, okay, if it goes beyond this, then there will only be the eccentricity. If the resultant is within this value, that is from here to here, then there will be no tension. So this will be the maximum value of the eccentricity, that is B by 6, that can be obtained. Okay, next question. The major resisting force in a gravity dam is water pressure, wave pressure, self weight of the dam or uplift pressure. Now think about it. Major resisting force in gravity dam. In the gravity dam, if you consider the elementary profile, then which one will be the major resisting force? Uplift pressure cannot be a resisting force. Wave pressure is the applied force. It is not a resisting force. Whereas water pressure is also a applied force, not a resisting force. Okay. So the answer that will be here applicable, that is the self weight of the dam, which will be the major resisting force here. Self weight will be major resisting force. Next question. The outlet discharge factor is the duty at the head of main canal, branch canal, watercourse or distributary. Think about it. Outlet discharge factor. We are talking about the outlet. This is duty at the head of watercourse. Okay. Option C will be the correct answer. And what is outlet factor? Outlet factor is defined usually as duty at the outlet. Okay. It is also defined as the duty of water at the outlet at the turnout that leads from the field channel and from the watercourse on the field. Okay, so outlet factor is actually the duty at the outlet of the watercourse. Okay, option C will be the correct answer, at the watercourse. Next question. The drainage water intercepting the canal can be disposed of by passing the canal below the drainage in. Which one is the system in which the canal is being passed below the drainage? Can you recall it? Okay, it is option C, that is superpassage and canal siphon. Okay, superpassage and canal siphon is the only one in which you can see that the canal is below the stream, that is below the drainage. Okay, in this, the drainage water intercepting the canal can be disposed of by passing the canal below the drainage. This is the superpassage or the canal siphon. Okay, next question. A river draining work is generally required when the river is meandering, aggrading, degrading or all of the above. In which case we will require river draining work. Just think about it. River draining work is provided in case of the meandering of the river. When there is meandering, the length will be increased. There will be both silting as well as the cutoff of the shore. So there we will require river draining work to prevent the bank of the river. Okay, so option A will be the correct answer. Next question. A land is known as waterlogged when the permanent faulting point is reached. What is permanent faulting point? When there is no water available for the plant to be utilized. Is that the case of the waterlogging? No, it is not. When gravity drainage has ceased, that is not a condition of the waterlogging. Gravity drainage, as said, there can be various possibilities. Okay, it is not only case of waterlogging. And in the case of the waterlogging, gravity drainage is still there while the water table comes at the top of the surface or near the top of the surface in the case of the waterlogging. While third option, capillary fringe reaches the root zone of the plant, which is the correct answer. Capillary fringes, these will reaches the root zone of the plant in which the waterlogging will occur. Okay, option C will be the correct answer. Next question. When the reservoir is full, the maximum compressive force in a gravity dam is produced at the toe, at the heel, within the middle third of base, or at the center of the base. Think about it. When the reservoir is full, in the condition of the full reservoir, it is not a case of the empty reservoir, the maximum compressive force in a gravity dam is produced. This is a gravity dam, let's say it is looks like this, and there is a it is full from here, there is a full supply here, so there will be some resultant force that will be obtained. Now maximum compressive force that will be obtained, where it will be obtained, just think about it. It will be obtained at the toe, at this point. Okay, at this point you will obtain the maximum compressive force, because you can see here that if you provide the moment from here and you find out the force at this point, then this will be maximum resisting force that will be present here. So the maximum compressive force that will be obtained at this point only. Okay, so option A will be the correct answer. This is the toe. At the toe of the dam you will obtain the maximum compressive force. Next question. The field capacity of the soil is 25%, permanent melting point is 15%, specific dried unit weight is 1.5. What is specific dry unit weight? It is ratio of the dry unit weight of soil to the unit weight of water. Okay, if the depth of the root zone of a crop is 80 cm, the storage capacity of the soil is 8 cm, 10 cm, 12 cm, or 14 cm. Think about it. Very easy question related to field capacity only. The formula for the field capacity, if you get into deeper, you will obtain it. You can use your notebook also to solve it. Take your time. I'm going to solve it here. Field capacity, first of all, field capacity is the weight of water retained in the some volume of soil upon weight of the same volume of dry soil into 100. Now depth of the water stored in the root zone, which is being asked here, that can be obtained by this specific dry unit weight, that is gamma d upon gamma w, into root zone depth into field capacity, or it can be written as field capacity minus of permanent melting point if the permanent melting point value is being provided. Okay, it is being explained very well in the video of irrigation engineering quick revision. You can find it out. I have provided the link in the description box. It is being present at this channel only. Now storage capacity is obtained from here, since specific dry unit weight is 1.5, which is being given here, into root zone depth, that is 80 cm present here, and field capacity minus permanent melting point, that is 25% minus 15%, so it will be 10%. So answer that will comes out to be 12 cm. Okay, 12 cm is the storage capacity of the soil. Next question. The peak of 4-hour flood hydrograph is 240 m³ per second. If the rainfall excess is 80 mm and base flow, which is constant, is 40 m³ per second, then the peak of 4-hour unit hydrograph will be. So here it is being provided the peak of 4-hour flood hydrograph for, that is 240 m³ per second, and now we have to find out the unit hydrograph. Now for the unit hydrograph, the rainfall excess is 1 cm, that is 10 mm, and here it is being provided 80 mm, that is 8 cm for flood hydrograph, that is being given here. Okay, now if we solve it, we will obtain that. Now first of all, from the peak value of the flood hydrograph, we will subtract the base flow, okay, which is being given here, base flow, and we will divide it by the total rainfall excess, that is 80 mm, that is 8 cm. So we will divide it by 8, because unit hydrograph is for 1 cm of the rainfall excess. Okay, so the answer that will be obtained here will be 25 m³ per second, and it is very important to memorize. These type of question is generally asked in the examination. So what is the procedure being followed here? You should memorize it. For unit hydrograph, you have to divide it from the given rainfall axis for this condition. Since these two are same, that is 4 are flood hydrograph and 4 are unit hydrograph we have to obtain, so we can use directly this formula. Okay, next question. The ratio of average value of the shear stresses produced on the bed and the bank of the channel due to the flowing water is less than 1, equal to 1, greater than 1, or equal to 0. Very easy question. If you memorize it, that we have explained it in the revision video of irrigation engineering very well. You can watch it there. In this question, the answer that will become greater than 1. How it is so? This is being explained in that video of irrigation engineering quick revision. In that you can find it out that at the channel bed, the tau naught is given by gamma W RS. That is the shear stress. And at the side slope, it is being given by 0.75 times gamma W RS. Now it is being given in the question that ratio of average value of the shear stress produced on the bed versus bank of the channel, that is at the side slopes. So at the bed it is gamma WRS, and at the side slopes it is, or at the banks of the channel it is 0.75 gamma WRS. So ratio of it will be 1 upon 0.75, that is 1.33. Okay, so the answer that here will be more than 1, that is greater than 1. Option C will be the correct answer. Next question. Pick up the correct statement from the following. Gravity water is harmful to crops. Hygroscopic water cannot be attached to the soil molecules. This is the reverse of it. Hygroscopic water is that water which is attached to the soil molecules, which is already present in the soil molecule inside of it. Capillary moisture held in the soil pores against gravity by surface tension is utilized by the plant. Which is the correct answer? Capillary moisture is the one that will be held in pores of the soil and that will be utilized by the plant. While the gravity water is not harmful to the crops, they just simply seep down and join the water table. Okay, so answer C will be the correct answer here. You can watch it here. We have explained it in the video of revision of irrigation engineering. This is the hygroscopic water which is being directly attached to the soil molecules. Okay, and gravity water is the one which is not useful because which directly seeps down, and it does not becomes useful to the plant, but these are not harmful. Okay, and the capillary water is the one which is mainly utilized by the plant. These are being held in the soil because of the presence of the surface tension. Okay, next question. The width of the Meander belt is the transverse distance between apex point of one curve and apex point of the reverse curve. Think about it. Or apex point and the crossing, or two banks of the meandering rivers, or none of these. We have to find out the width of the meandering belt. In the meandering of the river, we have to find out width of meandering belt. The answer will be option A, that is apex point of one curve and apex point of the reserve curve. In this you can see this is the meander width. This is one curve from here, starting from here to the reverse curve. This is here. This is not reserve, this is reverse curve. Okay, this is the first curve, this is the reverse curve. So the meandering width is the distance between, this is the apex point of one, this is the apex point of second, and the distance between these two is called the meandering width. Okay, next question. If the risk of the flood occurring in the next 10 years is accepted to 10%, then the return period of the design should be 1 plus 0.9 raised to power 0.1, 1 minus 0.9 raised to power 0.1, or 1 upon 1 minus 0.9 raised to power 0.1, or 1 upon 1 plus 0.9 raised to power 0.1. Just think about it. You can use your paper pen or notepad, whatever. In this question, you should first of all know the formula of the risk in terms of return period. Okay, so I'm going to tell you the formula for risk is 1 minus q raised to power n, and q is 1 minus 1 upon t. Okay, so it can be given by 1 minus 1 upon t raised to power n. That is the risk. Okay, in this video I have already explained the q. That is why it is directly being written as hydrological risk, that is r equal to 1 minus q raised to power n. Now here you can see that the formula that 1 minus 1 upon t raised to power n, if we have to find out t, then it can be written in the terms of risk. If risk can be written as r, then it is 1 upon 1 minus r raised to power 1 upon n. Now putting the value of risk here, what is the risk here? It is 10%, that is 0.1. So 1 minus 0.1 will be 0.9. raised to the power 1 by 10 will be 0.1. So 1 upon 1 minus 0. Raised to power 0.1, which is the correct answer. That is C will be the correct answer. Okay. Moving on to next question. The uplift pressure on the dam can be controlled by constructing cutoff under upstream phase, constructing drainage channels between the dam and its foundation, by pressure grouting in foundation. The correct answer will be, think about it. Uplift pressure on the dam. Uplift pressure can be controlled by, uplift pressure is from the bottom of the dam. Now this can be controlled by all of these, that is first, second and third. First of all, we will construct the cutoff under upstream phase. The cutoff will be placed to take out the water pressure, and constructing the drainage channel between the dam and its foundation. And we can also pressure grout in the foundation. These three methods are being used to reduce the uplift pressure. We can control the uplift pressure by doing these three things. Okay. Next question. The structure constructed to allow drainage water to flow under pressure through an inverted siphon below a canal is called siphon, super passage, super aqueduct, or siphon aqueduct. Now the structure which allows the drainage water to flow under pressure through an inverted siphon below a canal. First of all, canal is above and normal drainage is below it. Okay, so it will be a case of aqueduct in which canal is above and this is below. Now since it will flow under siphonic action, so it will be called as siphon aqueduct. Okay, the D will be the correct answer here. Next question. The difference in the level between the top of the bank and supply level in the canal is called, top of the bank and supply level of the canal is called berm, freeboard, height of the bank, or none of these. This is very easy question. Top level of the bank and supply level of the canal. This is very easy question. We call it freeboard. Okay, supply level means the highest flow level or the full supply level at which the canal can flow, and the berms are being placed little above it. The difference is called the freeboard. Next question, that is the last question of this video. If the irrigation efficiency is 80%, conveyance losses are 20%, and actual depth of watering is 16 centimeter, the depth of the water required at the canal outlet is 10 centimeter, 15 centimeter, 20 centimeter, or 25 centimeter. This is a very easy question. Just memorize these formulas. What was irrigation efficiency? What was conveyance efficiency? Okay, now there must be some losses, and finally the value that will be obtained is 16 centimeter. Actual depth of watering which is required is 16 centimeter. Now at the canal outlet, since there are two losses have been provided, first of all, irrigation efficiency is 80%. So this will be divided by 80%, that is 0.8, to obtain the value of the irrigation water required. And this conveyance loss is 20%. So we have to incorporate this 20% also. So we will again divide it by 0.8 to obtain the value of the water required at the canal outlet. Okay, this will be obtained as 16 divided by 0.8, and again we will divide it by 1 minus 0.2, that is 0.8. So answer that will comes out to be 25 centimeter. Okay, depth of water required will be 25 centimeter, that is option D will be the correct answer. Now what is the water conveyance efficiency? It is the water delivered to the field upon water diverted from river or reservoir or the canal, which is being given here. Okay, so from the canal, this is water diverted from the canal, and this is water delivered to the field. Between this there are 20% losses which was given in the question, which was incorporated into the answer. So here we will finish with the 30th question of this video. In the next video we will cover the question number 31 to 60. Until that, subscribe to this channel and stay updated.